this lesson, we're going to examine a new idea. It's called a similar triangle and also congruent triangles. And the way this idea works is we're looking at pairs of triangles. And these triangles have some similar properties. In particular, they have the same shape, but they're different sizes. So maybe one triangle is twice as big, 4 times as big, or a third as big. There's a relationship between them. By knowing that these things are similar, we can use the idea of proportions to actually solve. So, before we get started on the math part, let's talk about the theoretical part. To show things are similar, we have to have something called a similarity statement. So triangle ABC, that'll be the first triangle, is similar to triangle XYZ. Now mathematicians often look for shortcuts for things, so we have a symbol for similar. And it's a squiggly line here. So we would put the triangle ABC is similar to triangle XYZ. Okay, we have a symbol between them. Now when you're setting up your similarity statement, you have to be able to show they're actually similar. So there's 2 ways of doing this. Method number 1, which is our most common method, is to show that all the angles are the same. So if I have a diagram, their angles are labeled, maybe with numbers or symbols. I know what that symbol means. It means it's 90. And I notice that my other triangle has the exact same numbers in it. In particular, I only really need 2 angles. And the reason why is we know triangles add up to 180. So if the first 2 are the same, the third must be the same. Well, then I've shown that these 2 triangles, same angles, have to have the same shape. They can be different sizes, but they're the same shape. So I can write a similarity statement. Now notice this time triangle ABC is similar to NMO. This is not in alphabetical order, and it doesn't have to be. In fact, it rarely is, but it does have to fall in order of mathematical sameness. So if we look back at triangle ABC for a second, when I labeled ABC, I had a specific set of angles. A was angle 60, B was angle 90, and C was angle 30. Well, the second triangle has to follow the exact same order. So it had to start with the 60, and then the 90, and then the 30. Regardless of what the letters order are, the math has to be the same inside the triangle. So that's option 1, if your angles are the same. Option 2, which is going to allow us to solve problems, is to figure out that the side lengths are proportional. That is, there's a constant multiple between pairs of matching sides. We can call this the scale factor. So if I match up sides in this one here, okay, I'm going to take the biggest side from the first triangle and match with the biggest side of the second triangle. And then try the medium side of the big one and the medium side of the small one. And then the small side with the small side. So this is all from the big triangle. These are all from the small triangle. Well, every single one of those, when you divide them, 20 by 10, 16 by 8, and 12 by 6, comes out to 2. They all have the same scale factor. One triangle is twice as big as the other one. And so we'd say a scale factor of 2. Now here I've started the similarity statement. Can you finish it off? Triangle ABC is similar to triangle. So let's look for mathematical sameness. So ABC. So A started with the box, which means I have to start with the box over here. And then I went to B. Now B is this angle between the biggest side and the medium side. I'm going to put a little dot there to tell me that. Biggest side, medium side. Biggest side, medium side. That's got to be L. And then we went to C, and C is the one right here that's blank, which is one that's blank. So similarity statement is ABC is similar to KLJ. And sometimes it's helpful to add those symbols to your diagram, even though you don't know the actual values. You know they have to be the same size because they are proportional. All right, so I want to figure out if these 2 triangles are similar to each other or not. I have 2 options. Can I see if all the angles are the same? Which, well, I don't see any angles. So the other option is, do they have a scale factor? Is there a constant multiple? So let's give it a try. The biggest side in this triangle is 7.4. The biggest one in this triangle, 3.7. The medium size, 6.8. The medium size, 3.4. the small 6.5, and the small 3.2. When I divide the first one, I get 2. The second one, I get 2. And the third one, I get 2, but I have a little bit of a decimal there. It's 2.03. So what does that tell me? It tells me there's not a constant ratio between each of these. The scale factor has to be the same for all 3 comparisons. So that the fact that this isn't tells me these are not similar. One of the angles is slightly different than they were in the other triangle. Okay, so once we know things are similar, we have the 2 ways of proving it. All the same angles or that scale factor. There's some other things we can prove. So if the triangles are similar, well then, angle A has to be the same as angle J, following mathematical sameness. B has to go with K, and C has to go with L. We show that right here. We also know that there are proportional sides. There's fractions. In particular, the first 2 letters, AB, have to go with JK. That's this one. BC would have to go with KL. That's this one. And AC has to go with JL. That's this one. And every single time when we divide that, we'll get our scale factor. Now this idea right here is pretty important for us, because if I put some numbers in there, I can actually solve for other parts and pieces using the idea of the scale factor. Just before we get to that, one last big idea, something called a congruent triangle. This happens when your scale factor is 1. In other words, the 2 triangles are exactly the same size, and the same shape. They might not look the same, they've been rotated or flipped or twisted or something like that, but they're actually the same. You can see that because you have all the same sizes. We show congruency with this fancy symbol, an equal sign with this squiggly line. But other than that, everything else stays the same. We have a similarity statement, or congruency statement if you will. We have a symbol in the middle, and our 2 triangles follow mathematical sameness. You might see a congruent triangle from time to time, but we're not going to spend much time on them because not much you can really do with them. They're exactly the same, just different versions of each other. So let's go back to that similarity idea, where they aren't the same size, but they are the same shape. That allows us to problem solve. By using scale factors, we can set up a proportion, 2 fractions that are equal. And we can solve that by cross multiplying. So if I look at this diagram here, I know these 2 things are similar. I know that because 2 angles that are across on each other must be equal. And if I have a Z pattern, then these angles must be equal. And if 2 of the angles are equal, well then these ones have to be equal. So these 2 triangles are the same shape, they're just different sizes. That's going to allow me to set up a proportion statement. So I'm going to take the big triangle and the small triangle and match up sides that go together. So in the big triangle, the 5 is between the star and the dot. On the small triangle, that's the letter Y. In the big triangle, the 6 is between the dot and the little curvy thing right there. Well, the dot and the curvy thing is 4. And then my last set, I only have one left, X, must match with 3. Well, this looks like what we learned about problem solving, proportions. We can solve this by cross multiplying. Now I'd like to point out one thing here before I start. Make sure everything on the top is from one triangle, all from the big. Everything on the bottom is from the other triangle, all from the small. Otherwise the math won't work very well. So let's cross multiply. 5 times 4 makes 20. 6 times y makes 6y. So y is 20 divided by 6. Whatever that happens to be. Is that 3.33? Is that right? 3.33? Yeah. There's y. If I do the same thing for the next set, I can figure out x. So 6 times 3 makes 18. 4 times x is 4x. 18 divided by 4 is x. So x is 4.5. And I've quickly solved things using my idea of a scale factor. I didn't actually calculate the scale factor, but I knew there was one that allowed me to solve this problem. Let's try the next one. Okay, I got a big messy diagram here. I'm hoping you see two triangles though. You see a small triangle inside, and maybe a big triangle on the outside. Okay, so if I do the same idea, I've got a small and the big. And I'm going to do the small on top this time. Doesn't really make a difference which order you do it in. So what do I got? In the small triangle, I have a side of 15. And it's the left-hand side. In the big triangle, that is all the way from here to here. How big is that? It's not 15. It's not 5. It's actually the 15 and 5 put together. It's 20 centimeters. Okay, in the small triangle, I've got a side that's x. The corresponding big triangle goes from here all the way down to here. And again, it's not x or 4. If I take the idea from the previous side, I got to add those two things together, and I get x plus 4, which means I'm going to have to do a little bit of algebra. But I'm going to use the same procedure we did in the previous question. I'm going to cross multiply. 20 times x is 20x. 15 times that makes 15x for sure, but I need to think of this as having a bracket around it. I need to multiply the 15 by both of those things. So I get plus 60. Now I'm going to solve this. To solve things, I need to bring the 15 over to this side, put all the letters together. When I cross the equal sign, do the opposite operation. So it was a positive 15x, comes over to the other side, becomes minus 15x. Well, if I collect those, I get 5x. If I want to solve for x, I can get 12 in centimeters. And I've solved another one. Okay, last one. Okay, let's take a look at these diagrams. What do we got? Well, first question I need to ask myself is, are these similar? I don't have all three sides, so I can't prove proportions. And I only have one angle, which means I can't tell if they're the same shape. So I want you to stop sometimes, and when you get your homework questions, you're going to see this. Don't assume things. Let's say you can prove that they're similar. You can't use these ideas. And there will be questions where you can't prove they're similar. So you just say, I can't do it. This is not a possible question. However, if I were to add a symbol, say it's the dot down here, and I tell you these are equal, well, the fact that I have two equal angles implies that all three of them are equal. The third one has to be the same size, right? They have to 180. Means I can use similar triangles. So how would I use similar triangles in this case? What do I know? I know that 15 has to match with 10. So it's the big one and the small one. Okay, it's between the curve and the dot. But 8 would match up with this side, which I don't really know, and x would match up with this side, which again I don't really know. So I don't have any more things that I can put together right now. I can find y, but I can't find z or x the way I have it set up. So one thing I want to point out in this question, we know things about right angle triangles. I know it's right angle, it's got a box in it. We know something about Pythagoras. I'm hoping you remember a squared plus b squared is c squared. In this case, a and b are your two sides, and c is always your hypotenuse. So if I fill those in, I have an equation I can solve. To solve this, we're going to put the numbers on one side and the letters on the other. So I'll get, make sure you follow BEDMAS here, okay? 225 minus 64. That's going to give me 161 for z squared. And if I want to find z, I'll have to square root 161, which gives me approximately 12.7. Okay, once I know that, now I can go back up here and I can solve for all the missing parts and pieces. Let me go back to cross multiply. Yeah, 15 times y, I could get this one. This one's pretty easy. 10 times 8, so y is 80 over 15. 5.33. And now I can do the next one. And the way I'm going to do the next one, I'm actually going to use this fraction with this fraction. So I'm going to cross multiply this way, okay, just to make my life a little easier. 127 equals 15x. And you can use any two fractions you want to at a time. I skipped the middle one. I could have used y, but y is a messy number, 5.33333, so I didn't really want to use that if I could avoid it. And if I do it this way, though, I get x is 8.46. And you would have got the same answer if you used the y version. Depending on rounding, it might have been slightly different, but it's just easier to use ones that are whole numbers if you possibly can. Okay, so that's a little introduction to similar triangles, how we can prove that they're similar. Now we can solve some pretty simple problems by setting up proportional statements. Our homework is on the website right now. It's actually from our textbook, but we don't have textbooks yet. So try these questions, print them off. The answers are also on the website. You can check things out, just make sure things are going okay so far. If you're stuck, come see me and we'll go from there.